I am K. Gayatri from 3rd BSc Physics, Dr. Umayal Ramanathan College for Women, Karaikudi. My subject is Programming in C, Unit 1. Topic is Operators. In this video, we are going to study about the operators. Operators means symbol, and that tells the compiler to perform a specific mathematical or logical functions and operations. Operator is used to manipulate data and variables. C provides the following types of operators: arithmetic operators, relational operators, logical operators, assignment operators, increment and decrement operators, conditional operators, bitwise operators, and special operators. And first one is arithmetic operators. Arithmetic operators is all are binary operators. It means two operands are required to perform the operation. For all the basic arithmetic operations can be carried out in C. All the operators have almost the same meaning as in their other languages. Both unary and binary operations are available in C language. Unary operations operate on a single operand, therefore the number 5 when operand, where the unary minus will have the value of minus 5. For example, addition, subtraction, multiplication, division and modulus operators. There are also binary operator. And second one is relational operators. Relational operators are used to compare values of two expressions depending on the relation. An expression that contains relational operators is called relational expression. If the relation is true, then the value of relational expression is 1. And if the relation is false, then the value of expression is 0. The relational operators are less than, greater than, less than or equal to, greater than or equal to, is equal to, and is not equal to. And third one is logical operators. All the logical operators are available in C. These operators are used for testing more than one condition and making a decision. C has three logical operators. They are: first one is called and second one is called or, and third one is not. For example, and returns true when all the conditions under considerations are true, and returns false when one or more than one conditions is false. And fourth one is assignment operators. The assignment operators is values to a variable can be assigned using assignment operator. The assignment operators is a simple is equal sign. The assignment operator is used to assign the value to a variable. The format of an assignment statement is variable name equal to expression colon. The expressions can be a single variable or a literal, or it may contain variables, literals and operators. The assignment operators always takes place from right to left. And fifth one is increment and decrement operators. First, what are the increment and decrement operators? Increment operators is used to increment the value of a variable by 1. Similarly, decrement operators is used to decrement the value of variable by 1. C allows two very useful operators not generally found in other languages. These are increment and decrement operators. C supports two useful operators, namely increment plus plus, decrement minus minus. The plus operators adds a value 1 to operand. The minus operator subtracts 1 from operand. And sixth one is conditional operator. C supports the ternary operators, that is the conditional operator. The conditional operators works in following the format. For example, A equal to 11 a semicolon, B equal to 20 semicolon, X equal to A greater than or B question mark A colon B and semicolon. This format is also known as conditional operators. In these examples, X will be assigned the value of B. This can be achieved using the if-else statements. And seventh one is bitwise operators. C has a distinction of supporting special operators known as bitwise operators for manipulation of data at bit level. These operators are used for testing the bits or shifting them right or left. Bitwise operators may not be applied to float or double. And last one is special operators. C supports some special operators of interest such as comma operator, size of operator, pointer operators and member selection operators. The comma operator can be used to link the related expressions together. And next, the size of operators is compiled time operand, and when we used with an operand, it returns the number of bytes in operand occupies. Thank you.
In this video, we are going to see while and do while loops. So what is loops? Within a method, we can alter the flow of control using either conditionals or loops. So we can alter the flow of control using conditionals or loops. The loop statements, there are three loop statements: while, do while, for. Allow us execute a statement over and over. So like a conditional, a loop is controlled by a boolean expression that determines how many times the statement is executed. So here the boolean expression is the test condition given at the first, and the statement is the body of the loop executed. So the example for loop is, you may want to calculate the interest paid on the mortgage for each year of the loan term. The while statement. The form of the while statement is while within bracket opening angle bracket boolean underscore expression closing angle bracket. Next, opening angle bracket statement closing angle bracket. So here the boolean expression or the test condition given at the first, and the statement is the body of the loop. If boolean underscore expression evaluates to true, if the test condition is true, then the statement is executed, the body of the loop will be executed. Then the boolean underscore expression is evaluated again. If it evaluates to true, the statement is executed again. So if the test condition is true, the statement will be executed, the body of the loop will be executed. This repetition continues until the boolean underscore expression evaluates to false. So this repetition will continue until the test condition evaluates to false. So if it is false, the control will be transferred out of the loop. The while flowchart, boolean underscore expression, which means it is a test condition here. So if the test condition is true, the statement, that means the body of the loop, will be executed. The boolean underscore expression is again evaluated. If it is true, the body of the loop will be executed again. This repetition continues until the test condition remains false. If it is false, the control is transferred out of the loop. While example, print n asterisk int I is equal to 0 semicolon while open bracket I opening angle bracket n close bracket open brace system dot out dot print within bracket double quotation asterisk close double quotation semicolon I plus plus semicolon close brace system dot out dot print in open bracket close bracket semicolon. When n is equal to 0, I output I opening angle bracket n question mark. So if we apply 0 for I, and already we know n is equal to 5. So what is the output of this value? So here is the table for that. Next, the do statement. The opposite of the while statement is the do statement. The form of the do statement is do opening angle bracket statement closing angle bracket while within bracket opening angle bracket boolean underscore expression closing angle bracket semicolon. First the statement is executed. In this, first the body of the loop will be executed, then the boolean underscore expression, the test condition, is evaluated. If it is evaluates to true, statement is executed again. This repetition continues until the test condition, that means boolean underscore expression, evaluates to false. So if it is false, the loop will be terminated and the control goes to the statement that appears immediately after the while statement. So this is the flowchart of do. On reaching the do statement, the program proceeds to evaluate the body of the loop first. At the end of the loop, the test condition in the while statement is evaluated. If the condition is true, the program continues to evaluate the body of the loop once again. This process continues as long as the condition is true. When the condition becomes false, the loop will be terminated and the control goes to the statement that appears immediately after the while statement. Since the test condition is evaluated at the bottom of the loop, the do while construct provides an exit controlled loop and therefore the body of the loop is always executed at least once. Example for do statement: int I is equal to 0 semicolon double slash initialize do open brace system dot out dot print within bracket double quotation asterisk close double quotation semicolon I plus plus semicolon double slash update close brace while within bracket I opening angle bracket n semicolon double slash test system dot out dot print in open bracket close bracket semicolon. So this is the example for do statement. So if we apply I is equal to 0, if we apply it in the program that the value of I equal to 0, so if the program is executed, the output will be reached. Thank you.
In this video, we are going to talk about storage classes. Storage classes is nothing but storing data in the memory. Memory means main memory or secondary memory or register. In storage classes, there are 4 types of variables: automatic variable, external variable, static variable, and register variable. First, we are going to talk about automatic variable. Automatic variable is also known as local variable. Automatic variables are declared inside a function in which they are to be utilized. These variables are created when the function is called, otherwise it will destroyed automatically when the function is exited. So that it is called automatic variable because it automatically get destroyed when the function is exited. It is also called as internal variable because it is declared inside a function in which they are to be utilized. If any variable is declared inside a function without specification of any storage class, it is by default the variable is automatically taken as automatic variable. In this, the keyword auto is used to denote it is an automatic variable. Then the default value for local or auto variables is garbage value. The scope of this auto variable is available within the block in which they are declared. Now we are going to see about external variables. External variables are also known as global variable because it has an ability to access the outside of the block. This variable is both alive and active throughout the program. Since it is a global variable, it can be accessed by any function in the program. Automatic variables are declared inside the function, but external variables are declared outside of the function. Once a variable is declared as global, any function can use it and change its value. Because after declaring it as global variable, it can be accessed by any function in the program. In this external variable, we use extern as a keyword and its default value is 0. Scope of this variable is available throughout the program because it's global variable, they declare outside the block. Now it's a static variables. The value of static variable persists until the end of the program. A static variable may be either an internal type or an external type depending on the place of declaration. A static variable is initialized only once when the program is compiled. It is never initialized again. Internal static variables are those which are declared inside a function. The scope of internal static variable extended up to the end of the function in which they are defined. Therefore, internal static variables are similar to auto variables except that they remain in existence throughout the remainder of the program. Therefore, internal static variable can be used to retain values between function calls. External static variable is declared outside of all programs and is available to all the functions in that program. The keyword static int x and static float y is used. Now register variable. A variable should be kept in one of the machine's register instead of keeping in the memory. Since a register access is much faster than a memory access, keeping frequently accessed variable. Keyword register in count is used. Most compilers allow only int or char variables to be placed in the register. It is important to select the variables carefully for this purpose. However, C will automatically convert register variable into non-register variable once a limit is reached. These are the 4 storage classes that supports the C language. Thank you.
We are going to discuss the topic of call by value. Here, values of actual parameters will be copied to formal parameters, and these two different parameters store values in different locations. We have these two variables x and y. Let me declare this variable over here, variable x and variable y. Variable x contains value 10 and variable y contains value 20. What we are exactly doing this calling procedure, we are passing the values of x and y to the function definition, which is available over here. These value 10 and 20 will get passed to this variable x and y. Let me declare this variable over here, x variable and y variable. These variable now contain value 10 and 20. Now inside this function, we are changing the value of x to 20. That is what we are doing here. And y to 10, that is what we are doing here. So variable x will contain value 20 and variable y will contain value 10. Now note down that these variables are local to this function. When this function procedure finishes, we get back to this calling procedure. Then this variable will get destroyed. Whatever the changes made in this variable will not get reflected back to this variable. If you try to print the values of x and y when the output x equal to 0 and y equal to 20, which have the original values, this is what we need to understand about the call by value. In call by value procedure, you simply passing the values to the variable and not the variables itself. So whatever the changes you made to these variables will not get reflected back to these variables. This is called call by value.
We will see the C programming for sine series. Sine series is sin x equal to x minus x cube by 3 factorial plus x power 5 by 5 factorial minus x power 7 by 7 factorial plus etc. This will be the program void main int I comma n. Float will be declaring 3 variable in float. We are getting the value for sine, that is 45. We assume that x equal to 45. N is the number of iteration and 3 times we need to do this loop. N will be 3, so we getting input using scanf statement. So x and n we have taken and we calculate x equal to x into 3.14 by 180. Then we are initially the x value to a t and x value to sum. Now we are using for loop loop will go from 1 to n, that is 3 here. Okay, this will be the actual formula. After finding this value is t, we summing with sum equal to sum plus t, and we are printing I will be the number of iteration and the resultant sum will be the printed along with this. Here we will see the logic. The given value are x equal to 45, n equal to 3. The first step is x equal to x into 3.14 by 180. So we are calculating here x equal to 45. So 45 into 3.14 by 180. For easy understanding, I am writing like this 3.14. Otherwise, you can write 3.14159. 45 into 3.14 by 180, this answer will becoming 0.78539. This will be the x value now. We are initialing this x with t and sum. Now we need to, after this two line, we need to use this loop will running from 1 to 3 times. X equal to 1, we are checking whether x I less than or equal to n. Yes, that is true. Always a less than or equal to true, we are proceeding. So t line being printed, we are calculating t into x minus 1 into same value by 2 into I is 1 into x into I plus 1. We are getting the value as minus 0.08074. Next step, sum equal to sum plus t, so we are getting 0.70165. Next printf statement is printed. Percentage t interaction result is percentage f I comma sum. Now for loop being checked again. Now n will be 2. It is getting incremented, so I is being 2 and we are repeat the above step again. Still this condition I less than or equal to n will be the routine. 3 time loop will get going and finally the answer getting the way.